This is the second video in the Test 2 review, and it covers material on translations of graphs, graphs of tangent and cotangent, and graphs of secant and cosecant. In this problem, we're asked to graph y equals 3 plus sine of x. So this graph is going to look very similar to simply the graph of y equals sine x. However, there is going to be a vertical translation 3 units up. So when you're adding a number onto the function, what it's going to do is shift it up vertically by the number of units. But if it was negative, it would shift it down. So this is a graph of just one revolution of a sine wave from 0 to 2 pi if you're using the function y equals 3 plus sine x. So as you can see, we shifted the graph vertically up by 3 units, so it's starting at 3 instead of 0, and then it peaks at 4, and it has a minimum at 2. In this question, we're given the function y equals 4 sine of 7x minus 6. So we're then asked to find the amplitude, period, and phase shift. So remember, if you have a function that's in the form a sine of b times x minus d, your amplitude would be the absolute value of a, your period would be 2 pi over b, and your phase shift would be d. So what we're going to do is we're going to rewrite our function in this form so that we can solve our problem. So our function will now be 4 sine of x, or 4 sine, and we pulled the 7 out as our b. So sine of x minus, and we pulled out a 7, so this is now going to be 6/7. So our amplitude, which would be the absolute value of a, is 4. Our period, which is 2 pi over b, would be 2 pi over 7. And our phase shift would be 6/7. So remember, when you're given a function and you're asked to describe it, it's important that you get your function into this form so that you're using the correct values for a, b, and d. Here we're given a graph and we're asked, given that the form of the equation is either y equals cosine of x minus d or y equals sine of x minus d, what is the equation that describes this graph? So first we need to determine whether we're working with cosine or sine. So notice that if we were to shift this graph to the left, this peak here would hit the y-axis first, and so we can assume that this is a cosine wave that starts high and goes low. So we're working with y equals cosine of x minus d. So typically cosine, if we're starting on the y-axis, would start at 1 and then go down and come back up. So the point 1, however, is happening at pi over 4, so that indicates that we have a phase shift of pi over 4. So our graph is now beginning at pi over 4 instead of 0. In this problem, we're given the function y equals 2 sine of x over 3 plus pi over 3, and we're asked to describe the amplitude, period, vertical translation, and phase shift if the graph has any of those things occurring. So again, remember, if we have something in the form of a sine of b x minus d, then we can say that our amplitude is a, our period is 2 pi over b, and our phase shift is going to be d. So a vertical shift would occur if we had c plus a sine of ... everything that you see up here. However, since there is no coefficient being, or there's no integer being added to our function, there is no vertical shift. So we don't have to worry about that one. So what we are going to do, though, is rewrite this function so we have it in the proper form. So we're going to say 2 sine of 1/3 x minus pi. So here we had a plus, so actually this is going to be minus negative pi. So that's important to remember. We're looking for this form where we have a subtraction or a negative right here. So in order to do that, we're going to write this as negative pi. So going back to the problem, our amplitude is the absolute value of A, so the absolute value of 2, which is 2. Our period is 2 pi over B, so 2 pi over 1/3, which is equal to 6 pi. Our vertical translation we determined wasn't there, and our phase shift is going to be pi units to the left because we have that negative pi up here. So if your D is negative, that's indicating a phase shift to the left. If it's positive, then it's a phase shift to the right. In this problem, we're asked to graph y equals 2 tangent of 1/3 x. So the first thing that we're going to do with this problem is use b, which we can see is equal to 1/3, to figure out our period and our asymptotes. So the period of pi typically is just pi, so our period is going to be pi over b. So remember, this is different than if we're working with sine or cosine, where it would be 2 pi over b. So pi divided by 1/3 is 3 pi. So our period is 3 pi. And we're going to have asymptotes at bx equals negative pi over 2 and bx equals pi over 2. So we can plug in our 1/3 for b, and we find that this graph is going to have asymptotes at negative 3 pi over 2 and positive 3 pi over 2. Now that we've found our asymptotes, we can use those to continue to graph 2 tangent of 1/3 x. So I'm just going to erase this real quick so there's room to graph. So remember, we've got asymptotes at negative 3 pi over 2 and positive 3 pi over 2. So this isn't to scale, but we can just use it to get a general idea of what we would do from here to graph. So as we said, we have asymptotes at negative 3 pi over 2 and 3 pi over 2. So from there, we just need to worry about filling in the middle. So what we can do in order to figure out what our actual curve looks like for tangent is we can just pick values in between negative 3 pi over 2 and 3 pi over 2 and plug them back into our equation. So typically you're going to want to split it up into fourths, so you can use, for example, negative 3 pi over 4, 0, and 3 pi over 4 as your values. And if you plug those into your function, what you're going to end up getting is negative 2, 0, and 2. So we can use that to graph. So we'll have a point at 0, we'll have a point, so negative 3 pi over 4 will be somewhere around we'll be at negative 2, and then our 3 pi over 4 would be at positive 2. So I'm just going to pretend that that's where 3 pi over 4 is, and this is where negative 3 pi over 4 is. And then we can just draw in our tangent curve. So remember, with this, you're going to use b to find your asymptotes, then you're going to plug in values and graph it. In this question, we want to graph y equals secant of x plus pi over 4. So when you're graphing secant or cosecant, remember that you're going to want to start by graphing the reciprocal function, and then you can use that as a guide. So in this case, we're going to start by graphing cosine of x plus pi over 4. So I'm going to go ahead and do that real quick. Remember, it's just going to look like a cosine curve that has a phase shift of pi over 4 to the left. So this is just a quick sketch of cosine of x plus pi over 4. So we have our cosine curve with our phase shift to the left of pi over 4. So because secant of theta is equal to 1 over cosine theta, wherever cosine is equal to 0, we're going to have vertical asymptotes in our graph for secant. So we can just go ahead and sketch in these vertical asymptotes at our zeros. And from there you can just graph the corresponding little like U-shaped branches that you see in a secant graph. So we would have one here, we'd have one going on right here, and we would have one here. So our final answer for our graph of secant is what we have in the green. So remember, you're going to just want to start off by graphing the reciprocal function, and then you can use that to find your asymptotes, and then from there you can do your graph. All right, so just to summarize, if you're given a function that's in the form c plus a sine of b times x minus d, C is going to indicate your vertical translation, so it's going to be moving your graph either up or down. The absolute value of A will be your amplitude. 2 pi over B is your period. And D indicates your phase shift. So if D is positive, that is if it's in this form right here and your D value is positive, you're moving to the right. If you have a negative D, in which case it would look like x plus D. Now I know that's confusing, but it's because you're really looking at x minus negative D. So in that case, you're going to be moving to the left. Bearing that in mind, you're going to want to make sure that you're always rewriting your function. So if you have y equals 3 plus sine of 6x plus 7, you would rewrite that as 3 plus sine of 6x minus negative 7/6. Remember that our graphs for tangent and cotangent behave a little bit differently than sine and cosine. So if you're trying to graph tangent, remember that you're going to have asymptotes at bx equals pi over 2 and bx equals negative pi over 2. So you'll take your b value, plug in, and solve for x to figure out where your new vertical asymptotes are. With cotangent, you're going to see asymptotes at bx equals 0 and bx equals pi. So this is important when you're going through. If you're trying to graph tangent or cotangent, you're going to want to start off finding your asymptotes, and from there you can plug in values for your graph. And finally, if you're asked to graph cosecant, you're going to start off by drawing the corresponding sine graph, and then from there you can find your asymptotes, and then you can draw your u's. And if you're asked to graph secant, you're going to want to start off graphing cosine, and same thing, you find your asymptotes and you graph your u's. So this is the end of the second video for your test 2 review. If there's more problems you would like to cover, then you can go and look at the test 2 review online, and there will be an additional video covering the rest of the material that will be on test 2.